Today we will discuss the design of industrial structures. So the industrial structures in general are the structures or buildings which are made for industrial purposes, which includes storing of various materials and for meeting necessary requirements, especially the functional requirements. Generally, the industrial structures are made by steel, and as the introduction, we have any building structure used by the industry to store raw materials for manufacturing products of the industry. So it's like they're storing some materials which will benefit or which is used for the industry for making any product, and those are called as the industrial building. Generally, the industrial buildings are classified into low-rise steel structures, which is having a very less height, one-story buildings, and housing workshops are there, and also the big industries. To classify the industrial buildings, we have normal type industrial building and special type industrial building. So when you hear this name, the normal type industrial building are the regular buildings which are made or fabricated through the usual procedure. So those structures are well fit for different functions or different purposes. Special type are made on request, which will suit particular requirements. The normal type industrial buildings are shed type buildings with simple roof structures on open frames. These buildings are used for workshops, warehouses, etc. These buildings require large and clear areas unobstructed. So we need a clear area inside the big workshop for the object movements and for other storing purposes. And there should not be too much columns inside the building. The large floor area, it provides sufficient flexibility and facility for later change in the production layout without major building alterations. The industrial buildings are constructed with adequate headroom for the use of overhead traveling crane. So this thing we discussed in the video on gantry girder, the requirement for an overhead traveling crane and what are the various components of that. And as the last line, the special type industrial buildings are steel mill building, particular one, or any other things which are used for manufacture of heavy machines and production of the power. So we will see what are the major components of an industrial unit. Before seeing each individual component, let's see the figure. So this is the industrial building. You can see the building roof is made by truss, truss 1, truss 2, truss 3, 4, 5 and 6, and over the truss arrangement we have the purlins. These small lines are called as the purlin as shown here, and we have the sag rods connecting two purlin so that distance is kept same throughout the length, and this is the end truss, and these are the bracings 1 and 2. These are the cross bracings which helps in taking the lateral load as well as to keep the geometry of this area. And we have the columns throughout the length of the building, and girds are the arrangements, they're the horizontal members connecting the columns, which will help for resisting the wind loads. And the edge one is called as the eaves, and the middlemost one is called as the ridge line, and these are the braces. Then this is called as the gable end. This is the end, rear end, and we have the braces provided for vertical members also on this side or as well as the other side. And yeah, so these are the components. So we just see in the components, we will see in detail. The roof sheet is the material which is used to cover the shed. So it's the topmost portion of the any industrial building, and the roof truss is the structure. Just a minute. Yeah. So roof truss is the structure that is the compound of a number of line members connected to form a triangular form called as a truss. So the roof sheet is lying on the roof truss. In reality, the roof sheet is not directly lying on the roof truss. So we have the purlins, which we have seen here, arranged above the trusses. Sorry, yeah. A member supported on the panel points of two consecutive roof truss is called as a purlin. And like above the purlin, we are placing the roof sheet. After keeping the sag rods and the bracings, like sag rods are here and the bracings are here, which serve the purpose. And gird, we have seen that here. So the girds are the secondary structural members which provide support to roof as well as to the wall covering, and it also transfers the wind load from wall material to the primary frame. What's the primary frame? Primary frame is like this. This is a single frame. Like the frame is from here to here, and this is the truss portion over the frame. Back to the definitions. And eave strut, the member located at the intersection of the roof and the exterior wall. This is the eave strut at the wall roof, the edge. And next one is the bracing, which is the member which transfers horizontal load from the frame to the foundation, is known as the bracing. So you can see the bracings in the top region as well as in the wall region. The gantry girders, you have studied that in the previous video. They are the overhead traveling cranes and are used in the industrial buildings to lift the heavy materials, equipments, and to carry them from one place to the other over the entire floor area of one or more bays in between any two lines of building columns. So it's like a for a material handling, we are using the gantry girders. The crane columns, they are the crane columns used to support the craneway gantry girder. So this also you have seen in the last video. Then there are small but not very important, structurally important components like the partition wall, a permanent and the partition wall, staircase, which is for the functional requirement, and lighting and the ventilation for serving the purpose in functional way. So this is the figure of an industrial building. You may be asked to draw the industrial building figure and mark the important members as well as the important points and to write regarding that. And next one is the trusses. So how to classify the trusses? So you know the what is meant by truss, and the truss are the structural members or structural system which will carry the load either by compression or by tension. There won't be any bending to the members as the connections are pinned connection. So the first classification is the pitched roof truss, and this is called as a pitched roof truss, where there is a angle of slope and the pitch is defined as h by span, where h is the centermost height of the truss divided by total width of the truss, defined as pitch. This is the figure for Pratt truss, and normally the h is provided ranging from L by 5 to L by 6, and we have the Howe truss in this geometry, span truss, and the south tooth or north light truss, they are normally provided for ventilation and lighting purpose also. So this side there will be some ventilation as well as the lighting arrangements. And next type, there is no pitching. It is called as a lattice girder or parallel cord trusses. There are different arrangements in geometry for lattice girders as you see in the figure, both having different strength and both span for different length. And the next one is the trapezoidal truss, which includes the flat Pratt truss as well as the flat Warren truss. The flat Pratt truss are used for medium pitch and for long span. Similarly, the flat Warren truss is used for small pitch and for large spans. So these are the figures: floor girder, Warren truss. So in the syllabus, you have to study the different loads on a truss. So as you know, the dead load is an inevitable load on a truss. The main loads on trusses are dead load due to the roof covering material, purlins, sag rods, bracings, all will contribute to the dead load. Imposed load, the live load, maybe a man has to walk through the trusses during the fabrication, and the bin load, and there may be chances for seismic load, but not directly on the truss. The dead load are due to the sheeting or decking and their fixtures, insulation, false ceiling, weight of purlin and self-weight. This load may range from 0.3 to 1 kN per meter square and is calculated as per the table 1 of IS 875 part 1. The weights of purlins are known in advance as they are designed prior to trusses. Since the weight of truss is small compared to the total dead load, live load, etc., considerable assumptions are to be taken in account of weight of truss, and it will not have very great impact on the stresses in the various members. So normally the total weight of truss structural system will be very less compared to the acting loads. So we are assuming some value for the self weight and we are cross checking it after the design. And the live load, it ranges up to 2 kN per meter square, and we can use the following formula to use the for finding the live load. So W is equal to 20 plus 6.6 into L is the equation, where W is the weight of truss in Newton per mm square and L is the length of span in meter to find the weight of the truss. Continuing with the live load, for up to 2 kN per meter square, the following formula is used to get the approximate value of the weight of the truss. And for welded type of trusses, the self-weight of truss can be calculated by the equation W is equal to 53.7 plus 0.53 into A, where A is the area of one way. And for live load more than 2 kN per meter square, here it was less than 2 kN per meter square, the value of W may be multiplied by half of the actual live load in kN per meter square. And generally the live loads are calculated as per the IS 875 part 2. So the figure shows the corresponding clause in the IS 875 part 2 for finding the live load acting for different types of roofs. Like for the whether the depends on the slope and for whether access is provided for walking through the trusses, and so other things depends on the calculation of the live load. Yeah, the next important one is the wind load, because the pitch slope of the roof is very directly affecting factor for the wind load calculations. The wind load should be calculated as per IS 875 part 3. Since earthquake load depends on the mass of the building, earthquake load does not govern the design of light industrial buildings. Thus, the wind load will govern for the design of normal truss roof. And we have to consider the load combinations for dead load plus live load, dead load plus spin load, and dead load plus live load plus spin load, which will be the third one will be the most critical one for the analysis. And coming to the design of industrial building, the design of industrial building includes the design of the following components. So we have to design the roof truss. So we just analyzed how to find the various load acting on the roof truss, and then after analyzing the stresses, the member bending, like not bending moment for the truss, the axial compression value, tension value, we can design for the various members, as well as the connections can be designed. The crane country girder has been taught in the last video. The gable rafter, side rail, gable column, gable wind, vertical side bracing, rafter bracing, column and bracket connections, column bases and foundations are the individual component design, which we'll see in the coming slides. So to sum up the design procedure for trusses, it depends on the span, lighting, roofing materials available, type of truss, and is decided and it's based on the all these factors. The type of truss is decided, and the line diagram on which shape or what shape of truss is required is found out, and the various loads acting on the roofs are estimated. After that, the purlins are designed and the loads acting at the panel point of the truss is computed. Then the roof truss can be analyzed by any suitable method, and the member design forces are computed using the various load combinations, and it can be designed after giving appropriate load factors. The compression members are designed by taking the sections as angular or tubular sections. The principal rafter is designed as a continuous strut, and all the compression members are designed as discontinuous struts. Tension members are designed as angle, flat, or tubular sections, and the single angle tension members have a twisting tendency, and it produces the eccentric force at joints. Therefore, double angle sections are provided. So this gives the guidelines. Normally, compression members are designed with angle or tubular sections, and tension members are designed with the single angle tension members. And the principal rafters should be designed for discontinuous members. Coming to the gable rafter, the gable end of the industrial building is divided into a number of parts of particular spacing, each by providing number of gable columns. The gable rafter is supported over the columns. Loads on the gable rafter are determined, and then you can design for the bending moment. If you quickly see the figure, so these are the various components for the industrial building, and once you finalize the truss geometry, you can design for the truss individually. Then after arranging all the trusses, then you have to analyze in START or any other structural software to find the loads acting or the member forces on these individual components, and you have to design accordingly. It's the main base design things. And design of girds. After calculating the loads and corresponding maximum bending moment, the selected section is checked, and for combined maximum compression and tension stresses, they are checked. And we have the gable columns, which are also the gantry girder columns. After calculating the loads and corresponding maximum bending moment, the selected section is checked for combined axial compression and bending. And the bracings, it can be either vertical bracing on the walls as well as the rafter bracings on the roof, and the forces acting on the braces should be analyzed, and the members should be designed. So that's the end of design of industrial buildings in general.